if I have three sequence ABC, if my sequence B always is squeezed between two other sequence, and these two other sequence have the same limit, then my sequence B also have the same limit. This is called squeeze theorem. If I have this, my Bn is squeezed between An and Cn for On. Then what? If An and Cn have the same limit, then Bn converge to the same limit. If I want to write it as a logic sentence, this will be the logic sentence. I have An limit L, so I have 1. I have 2, what does it mean? Cn near L, under your gap, for any n larger than n2. Notice that n1, n2 does not need to be the same number. So now, what is 3? I rearrange 1. So absolute value, I can remove the absolute value, right? So I can have this. Just recap, this is my absolute value. And this is 5. Absolute value smaller than 5. That means what? All the x give you this V line below 5. Then the x range is this region. Then it will be between 5 and negative 5. Then I have 3. Same for 2, I can get 4. So basically 2 get 4, 1 get 3. Okay, then what's next? I now move the L to the both sides by doing what? I just add L in the whole equation. Then this cancel out. I have L here, so that's why I get this. So 3 give me 5. I add L in the both thing on 4, give me 6. So that's how you get 5 and 6. So now I have 5 and 6. And by assumption, An is always smaller than Cn. So I can combine 5 and 6, right? So I have this big chunk of thing, but An is smaller than Cn. So An is smaller than Cn. Also, Bn is squeezed in the middle. So An smaller than Bn, smaller than Cn. This part is this part. This part is this part. Okay? This ABC is this ABC. So now I have this. And what's our goal? Our goal is to prove Bn converges to L. So that means I want to get something in the end like the last line. So that's the idea. I just try to rearrange stuff such that it looks like this in the end. I have this thing. What I'm going to do? Well, my focus is now Bn, right? I don't care, and I don't care. So I have this. And since I have inequality here, so that's why I have inequality here. I have inequality here, so I have inequality here. Then this step go to here is just this step go to here, the opposite. So that's why I get this. And the tricky part is, this is true for n larger than n3. That means for this An, the epsilon delta is n larger than n1. For this Cn, the epsilon delta is n larger than n2. Then for this Bn will be n larger than n3. What is the relationship between n1, n2, and n3? Is that I take n3 as the largest of n1 and n2. Suppose this is my sequence. An and Cn converge to L. So for An, it's orange, right? So I use a red pen. It cut here. This is my n1. For Cn, it cut here is my n2. Then when will my Bn converge to L? It will be converged after here. So I can say this is my n3. What's n3? The max of n1 and n2. That's why I have this. And this is true, right? If this, I have this, so therefore limit of Bn equal to L. This is true because of definition. We said that if a limit converges, then you have this one sentence 2. Now I have sentence 10. That means limit B converge. And all the thing I do here is just to prove this is true. That's it. And what's the application here? You use this, you now can prove this guy equal to 0. Power 2n divided by n factorial. This is my Bn. I just need to make an An and Cn. So this is the idea. This is my Bn. So now let's look at what does it look like for the An. Well, I can just say An is 0, okay? And then what? 2 to the power n means 2, 2, 2, 2, 2, 2, 2, 2. And n factorial is this, right? Okay, and of course there's a divided by 1, but we don't care about 1, so I have this. And then here's the funny part. This is 1, so I don't need to look at it. Then all the thing here are smaller than 1. So of course I have this. And I keep the last guy here. So I have this thing. Why I keep the last guy? Because under it is an n. So now I have this. And limit n go to infinity, this guy is 0. So I have a sequence An squeezing Bn with Cn, and this guy converts to 0, this guy converts to 0, so the middle guy has to converge to 0. So what are the tricky part here? There are two tricky parts. The first part is you need to recognize you have to use squeeze theorem for this kind of problem. How do you know? Experience. Tricky part number 2, you need to construct An and Cn. This gives you a Bn. I didn't give you An and Cn, so you need to make the An and Cn, you need to know that An and Cn need to converge to the same limit. So this is the hint, how you construct An and Cn. And here's another example. Suppose I have An is bounded, and I have limit Bn equals 0, then limit An Bn is 0. Okay, this is a proof, no time to talk about it, but let's talk about this one. How do you work on this thing? Turns out this thing is 1. Because this guy is bounded, the absolute value of this thing is 1. So I don't care how it flipping between 1 and negative 1, this guy as the largest value is 1. But this guy keeps growing, right? So I can do this. I just divide the whole expression by square root n. So I have something like this. And then now what? I can distribute it to the two parts. And then limit here, I can go inside each term. Why limit 1 is 1? It's not because this is 1. Because 1 is a constant sequence. 1, 1, 1, 1, 1, 1, 1, 1, 1 for all n. That's why you have 1. Okay, and now I do this, and this is 0, so come on,